I want to talk a little bit about using the 6 dB drop method for length sizing a defect. And excuse my crude drawing, but this drawing shows this is a flaw. A flaw maybe in a weld, a crack, and these are the ultrasonic transducer. Well, if you take that transducer and slide it back and forth at an equal distance, parallel to that defect, you can walk that signal along it. Now, if the probe is right in the middle of that defect, and we adjust our dB, our amplitude, to we're at 100% full screen height, right here, our transducer hitting that flaw, we would adjust our dB to 100% full screen height. Now, when we move to either side, either end of that, the same distance, holding that transducer at the same distance from our defect, providing that it's a a fairly straight defect. When we get to the ends, half of our sound energy will strike that defect, the other half will pass by. Same way on this end. Well, when that happens, when half of our energy misses that defect, we get what they call a 6 dB drop. 6 dB drop means that our screen, our amplitude will drop from 100% full screen height to 50%. Half of our amplitude, half of our energy is lost. That is called 6 dB. That distance halfway down is a 6 dB drop. What we would do, we would mark the transducer here. That would mark this in the defect. And when we go on the other end, we would do the same thing when the signal drops down to 50% of the signal, or a 6 dB drop. So let me show you real quick. I have a 70-degree transducer, and I'm shooting at this 0.6 deep hole. Let me run that. Take my dB up to 100% full screen height. So right about there, that's 100% full screen height. My dB is 66.6 dB. That's my gain to get a reflector from that hole to 100% full screen height. Now if I subtract 6 dB from the 66.6 and take it down to 60.6, the amplitude of this signal will go from 100% full screen height to 50%. So let's do that. Go from 66.6 down to 60.6. And where's my signal? Sitting right there at 50%. That drop, that's a 6 dB drop, means that your screen the amplitude will drop 1/2. So let me show you an example. And this is a good example because you can see it, and seeing is believing. I have a weld here, and it has a lacquer root penetration. And here's that lacquer root pen. And it basically starts at, that lacquer pen starts at about 1.5 inches and goes out to about 2.5 inches. So from zero, that defect starts at about 1.5 inches, and then the length of it is about 1 inch. Well, what I did was I transferred that defect right here. Starts at 1.5 inches from zero, and it's basically 1 inch long. So we can physically see it, and it gives us some confidence that we know what we're looking at. Well, let me put some coupling on here, and this is a 70-degree transducer. This a 4 megahertz is good for finding ID connected defects like in the root. So right here, and my range is 3.7 inches, so my ID of this weld will show up right at mid-screen. So right there, see, I'm looking right about in the middle of that weld and seeing that that lack of root penetration. So let me take this signal, let me move the gain up so that signal is about 100% full screen height. So right about there. So, and as you can see, the defect, it varies a little bit. Let me take a little bit of gain out. So that's about 100% full screen height. So let's move this guy over here. I'm pretty much hitting in the middle of my defect. And let me see, let me put in a little bit more gain to bring it up. So let's go to, so I'm pretty much hitting in the middle of my defect. And as you can see, it's my signal is just about 100% full screen height. Let me put a little more coupling on here, squeezing it out. There we go. Take her down to about 100%. So let me go to the far end here and see where that defect drops off to about 50% full screen height. Right about there. Right there. I'm pretty much at 50% full screen height. Let me take my marker and mark the center of my transducer. So on the plate, I'm going to the center of my transducer. I'm drawing that. From 100% full screen height to 50, I lost half my amplitude. That's a 6 dB drop. Let's move back across this guy. Here's our defect again. And now let's move her down till move her down till I'm about 50% full screen height again. Slide on down along there. Right about in there. I'm 50% full screen height. That looks about good. Let me mark the middle of that transducer. So that's marked. Now let's take a measurement. Here's my marks are right here. So if I go from 0 to that first mark, it's right about 1.5 inches. So that matches up with what I transferred from the back side. And the length of that is almost a little over 1 inch, like 1.05 inches. And that looks very, very close. So see, using the 6 dB drop, moving to the extremities of that defect where you get 50% loss of your dB, 50% less loss of your amplitude, that mark in the middle of the transducer, that is the edges or the ends of your defect.